I found this really old school simulator that might help with the position, velocity, and acceleration graphs, and I'm going to just try to do as many scenarios as I can think of to help you understand this. So here we have our guy, and he's at a position of 0. And so we can make a move in the positive direction, so to the right, and we can make a move in the negative direction, so to the left. Now, if I just let this play, he's going to be standing at the 0-meter position spot. And notice how my position, velocity, and acceleration are all just reading 0. If I give him a velocity, let's say give him a velocity of 1 meter per second, he'll start moving to the right. And you'll notice that my velocity graph is at a constant 1. And my position graph, now I'm moving away from the origin. And so I have a slope, and the slope is going to be 1 meter per second, so 1 meter every second, but a constant slope, and that's going to be translated over here. He'll stop at the wall, and so we can pause the simulation and kind of look at this. So as he moved away from the origin, his position got further and further away from 0, and the slope of this position versus time graph is the velocity. And since the slope is constant and positive, our velocity here, when we graph it, is constant and positive. Over here, we're looking at acceleration, and other than the little boost in acceleration to get him started, my acceleration was 0 the whole time because my velocity isn't changing. So we can reset this, and we can go in the negative direction. So if I start this, again, my position, velocity, and acceleration are all 0 because we're not moving. And I can make this -1. And when I hit enter, you're going to see him move to the left. And what you'll notice is that I'm going to start from the origin, and I'm going to move further and further away from the origin at a constant velocity. So the slope here is constant, and that's reflected in our velocity trace. So this is just a straight horizontal line at the -1 meter per second mark. And so that'll go until he hits that wall over there. So now if we take a look at this, we have a negative slope, and that's reflected over here where we have a negative velocity. So we can zoom in and kind of look at this more closely. That's reflected here where we have a negative constant velocity. Notice the slope isn't changing, and that's why we have a flat or a horizontal line here. Our acceleration, other than our starting and stopping, was 0, and that's reflected in our acceleration trace sitting at the 0 mark. Now, I'm going to play this, and let's give our guys a velocity of 1 meter per second. And then during this, let's make him stop. So if I'm at 0 meters per second, now he's just standing there. Notice how my position time graph is now flat. And so my position isn't changing. My velocity, the slope of this line is 0, and so my velocity and acceleration are both 0. If I want him to go the other direction, I can make this -1, and he'll start walking back. And what you'll notice is that my position is going back towards the origin. And once I pass the origin, what you're going to see is that it's going to go into the negative region. So I'll stop it there because you can't see the graphs anymore. If we zoom in on our velocity trace, we're going at a constant velocity here, and you can see that by the constant slope in the positive direction. So we have a positive velocity. That means I'm moving to the right with a constant velocity. When he stopped, the slope of my position time graph is 0, and so my velocity is 0. And then at around 5 seconds, I made him walk in the opposite direction, so a negative velocity, and our slope is negative. Once he passed the origin, the 0 point, then the position becomes negative. So the 0 position is how far from the origin our object or our person is. So when you're moving away from the origin in the positive direction, you're going to have a positive slope. If you're moving away in the negative direction, you're going to have a negative slope, but you're still moving away from the 0. Here we're walking back towards the origin, so we're getting closer and closer to 0. Okay. One more thing with constant velocity. So I'll play this, and we'll do 1 meter per second. And so he's moving, he's moving. Now I'm going to flip him. I'm going to flip his direction. So we're going to make him go -1 meter per second. Notice how you get an inflection point in the position versus time trace. So this inflection point is where you're changing direction. Here I'm moving away from the origin, so a positive slope, and I'm moving away from the origin. Here I'm moving back towards the origin. So I stopped it when he was at the origin, so that's why my position again is 0. If I let him keep going, he's going to be moving away from the origin, but in the negative direction. So my velocity is still negative. I can flip him around. Let's make him go 2 meters per second to the right. And what you'll get is a steeper slope in the positive direction. Once he passes the origin, now he's in the positive range for his position. So these inflection points in the position time graph are changes in direction. They're reflected in the velocity time graph, where in this region, you're moving in the positive direction. In this region below the 0, you're moving in the negative direction. So if you cross over the 0 on the velocity time graph, you changed direction. Okay. Let's look at acceleration. So let's give him an acceleration of 1 meter per second. I think he's going to end up going pretty fast. But if we start at a position of 0 and a velocity of 0, you're going to watch him go faster and faster. So notice how he's speeding up in the positive direction. Notice how the slope of our position time graph, as we zoom in, is no longer constant. The slope for the position time graph is changing. And so here he's moving in the positive direction, and his velocity is increasing, and that's reflected in the velocity time trace. So again, we can zoom in and see this more closely. But we have a constant increasing in the velocity down here. Now my acceleration is hard to see because I made it small relative to that scale, but it's constant and positive above the 0 mark. If I accelerate in the negative direction, you're going to see him start to move to the left, but our position time graph should go into the negative range, but still be parabolic. So you're seeing that the slope isn't constant here, it's changing, and that's reflected in our constant change in velocity over here. So because we're moving in the negative direction and we're speeding up, we have a negative slope here in the velocity. And then if I zoom in, we have a negative acceleration. Okay. So let me see if I can show this. Let's give him a velocity of 10 and an acceleration of -1. We'll just see how this goes. So in this case, my velocity is going to be to the right. So he's going to start at 10 meters per second, but the acceleration is going to be to the left because it's negative. That was probably too fast. Let me try that again. Let's make his velocity 2 and his acceleration -1. Okay, hold on. We'll make his velocity 2 and his acceleration -0.5. So what you're seeing is that the graph is flattening out until he comes to a stop. And so we start with a steeper slope and end with a less steep slope. And so our slope of our position time, again, is our velocity. And so what you can see is that he was slowing down, and so our velocity is getting closer and closer and closer to 0. You probably also noticed that he turned around. If I keep a negative 0.5 meter per second acceleration, he's actually going to turn around and start moving in the opposite direction. So that would be him speeding up. So we can let him do that. And so he's going to move more and more in the negative direction, faster and faster and faster in the negative direction. We can do the same thing if we give him a positive acceleration. Let's give that 0.5 and a negative velocity. So he's going to start by moving in the negative direction, but he'll be slowing down because the acceleration is in the opposite direction. So you can kind of correlate as he's moving in this direction, he's slowing down. And so his position versus time is becoming flatter and flatter. And that's reflected in this graph getting closer and closer to 0. So I'm going to leave a link to this simulation in the description for this video, and you can kind of play around with it yourself and do these different scenarios. And then you can test yourself. If I have someone moving at a constant velocity, you can change the initial position and see what happens. You can change the initial velocity, acceleration, and make predictions. And I think that'll help you answer questions with these graphs.